All right, we are now recording. By the way, if anyone's not cool with being recorded, please speak now and I will delete the recording when we're done. And it looks like we're recording now. For those of us just joining the recording now, sorry, I forgot to start the recording earlier, but we're just getting started here on the slides. We're talking about an overview here of lucky imaging, and this is the basic technique that we use for planetary imaging, where we're trying to freeze the seeing and take some very short exposures through a video, and using those extremely short exposures on the order of milliseconds to try to capture these moments in time where the view of the planet is pristine and undisturbed by the atmosphere. And we're talking about taking tens of thousands of these things in a video. And once we have that video of tens of thousands of these really fast exposures, we can throw out the worst ones. That's the lucky aspect of it. We're trying to get lucky and get lots of good ones. And ones that are left over, we're going to stack those up together. And after aligning them, which is all automatic, we'll see how that works. And then you get this thing that looks kind of blurry, but you can sharpen it because it's this average with these mathematical properties where you can throw wavelets at it and reconstruct the detail from that stacked image. It's kind of magical, and we'll see how it works shortly. But lucky imaging is not magic. Seeing still matters. If you're going to go out on a night with poor seeing, you're not going to get a good picture. There's just no getting around it. It doesn't matter how fast your exposures are. You got to have good seeing to get a really good picture. So that's another way of thinking about lucky imaging. It's not just getting those lucky sub-exposures. You also got to get lucky in just being out there on the right night. And that's kind of the lottery piece of this whole hobby here. Anyway, it all starts with the gear. So I have learned the hard way that if you have anything less than a 9.25-inch aperture, you're going to have a very hard time getting photos that you're truly happy with. You know, you can get good photos, you know, don't get me wrong, like you'll still impress your friends and family, but if you're like shooting for things that can, like, you know, go head to head with like Justin, with Damian Peach, or, you know, Christopher Go and people like that, or the astronomy picture of the day, you need something bigger. And 9.25 inches is kind of the sweet spot of like the smallest you can go and still get awesome results. There's a guy in the club, Bill Costring, who's also an awesome planetary imager, and that's what he uses, a Celestron 9.25 inch, and he gets great results out of it. But if you have a little bit more budget, you can go to the 11 inch and get even better results. And if you're like super obsessive, you can go to the 14 inch, and that will handle any seeing that the world can throw at you. It's going to be very rare that you're going to get a night where that 14 inch is going to make a difference. I find that the 11 inch is a really good sweet spot of being, you know, not so heavy that I can still handle it. And I can also put it on a mount that's not like super crazy expensive, because it's not so heavy that you need like a really expensive super heavy duty mount to carry it. So 11 inch seems like the sweet spot to me. I have an Edge HD. You don't need to get an Edge HD. I mean, in practice for planetary imaging, you're just going to be imaging this tiny little thing in the middle of your mirror, right? So the edge doesn't even matter really. So you can get that if you want to. It has some nice features like extra vents and, you know, lock knobs for the primary mirror. But, you know, if you don't want to spend the extra money for the Edge HD feature, you don't have to. But, you know, in general, you do want to be using something with a long focal length. And that's why most of the planetary imagers use a Schmidt-Cassegrain telescope, because, you know, the design of those telescopes is such that the light bounces down, bounces back up to the secondary, and bounces back down through the primary to your camera. So we get these really long focal lengths that way. You want to have that like really high magnification, obviously, because we're trying to get really fine details on these planets that are really far away. So, you know, it's not like a deep sky where you're trying to capture like a degree of the sky. We're trying to get, you know, fractions of arc seconds here instead. And even that focal length isn't going to be enough. We need to boost that further with a Barlow lens. So a Barlow lens is just a way of magnifying that further and further extending your effective focal length. I use a 2.5x Barlow lens on my setup here. Some people use a 2x, some people use a 3x. I kind of split the difference and get a 2.5x, and I get pretty good results out of it. For times like now where things are near opposition, especially if it's Jupiter or something like that, you could probably get away with 3x, but 2.5x seems to be a pretty happy medium for me. I'm just using a cheapo house brand from High Point Scientific, and it works well enough. There are some people who say you should spend more money on it. TeleVue is kind of the name brand there that is the most revered, so if you got the budget for it, go for it. And Mauricio has a question. So a Barlow doesn't kill your image quality. I notice I can't focus my camera on a reflector without one. Can't focus your camera without a Barlow. That's interesting. No, it doesn't kill the image quality if you get a quality Barlow. it is gonna, oh yeah, I mean, Teleview makes Barlow lens. I think the PowerMate is a Barlow lens, isn't it? I've never actually owned one, but if anyone is familiar with the Teleview PowerMate series, unmute and educate us. um, but anyway, back to Mauricio's question. I think, because you're magnifying things more, like if you're actually magnifying beyond the resolution of what your telescope is actually capable of producing, that's going to be an issue, right? So if you're just magnifying stuff that isn't there, a Barlow is going to make things worse. But in the case of planetary imaging with a large aperture instrument like a 9.25 inch or an 11 inch, you do have that resolution available to you. That extra aperture is what gives you the resolution you want. And as a result, you can get away with magnifying that through a Barlow lens and actually get more information on the sensor of your camera as a result. The PowerMate doesn't change the focus position when inserted. Oh, okay, that's a cool feature. Yeah, to be fair, my cheapo 2.5x Barlow lens doesn't change it too much either. It's a little bit off, but not as much as you might think. So, but that's definitely a nice feature to have, because focusing, as we'll see, is a very important step of this whole process as well. For the camera, I'm just using a ZWO ASI 224MC. That's that little red thing on the end of the tube there. Like I said, it's like a $200 camera. It's nothing fancy. It's just a glorified webcam, basically, sitting on the back of my Barlow lens. And it gets great results. If you want to spend more money, you can. I think there's a 174. The big boys use monochrome cameras instead of one-shot color, and they use filters. But I find that's just adding more trouble for not a whole lot of gain. If you've seen the pictures that I posted, we're all done using this camera. It's just a one-shot color camera. Yes, if you're using filters, you can do fancy stuff like getting different, methane bands on planets and things like that. But personally, I like to be able to go out there and just start taking pictures. And the more gear I have to fiddle with, the less likely I'm going to be to actually get out there and take pictures. And really, the whole secret to success with planetary imaging is just being out there. So the more you're out there, the more success you're going to have in getting good pictures. So lower that friction to getting outside with your equipment if you can. My mount is a Software Bisque MyT, or Paramount MyT, it's sometimes called. And I do use that for my deep sky work as well. So it is a pretty good mount. It's not cheap. But again, for planetary, you can get away with less. As long as it's rated to handle the weight of your optical tube, you're good. And you're not even putting a bunch of extra equipment on that tube either to weigh it down. Like that camera weighs nothing. Barlow lens doesn't weigh a whole lot. That's about it. I do have this big fancy dew shield online. That's that big thing on the left of the tube there. That's there, well, to prevent dew, because that is a big problem in Florida. But also, it's also to block out those street lights that you see. So it's kind of serving as a light shield as well. But that does add some extra weight to the system as well. Oh, thanks, Leonard, for talking to Mauricio about the focus issue he was talking about. Appreciate that. Cool. All right, also there's a gizmo called an atmospheric dispersion corrector. I have one, I've never used it. There are a lot of imagers who swear that you should always use it, but the rule of thumb I use is that if a planet you're imaging is above 30 degrees altitude in the sky, you can probably get away with not using it. And the good thing about living in Florida at our southern latitude is usually the planets are above 30 degrees latitude in the sky. So if you're living up north, you absolutely need an atmospheric dispersion corrector. It's just a little device that lets you correct for the refraction of the light coming from the planet as it goes through the atmosphere. And that's going to be more of an issue as it's lower in the sky, because the light will be passing through more of the atmosphere in that case. But if it's relatively high in the sky, like Mars is right now, Mars is awesomely high right now, you really don't need it. So it's just one more thing to fiddle with that you don't necessarily have to fiddle with. But if it's low in the sky, yeah, you probably want to fiddle with it. Most important, you need a laptop that has a really fast hard drive with a lot of space on it and a USB 3 connection. You'll find that the biggest technical challenge to this whole thing is just trying to capture that video fast enough. So when you're taking 5 or 10 millisecond exposures in a video file, we're talking like 200, 400 frames per second. That's a lot of data to push through that wire, right? So not only does it have to get pushed through your USB port, it also has to get ready to disk that fast as well. And it's really, really critical to have a fast hard drive and a USB 3 port. Pretty much everything comes with USB 3 these days. But you want to make sure you can write that data as fast as it's coming in. Otherwise, it's going to back up, and you're not going to capture all the data that you want. And finally, of course, some mosquito repellent, because it's Florida. For software, hopefully you download some of this stuff ahead of time. We'll be playing with it shortly. Fire capture is what we use for actually doing the capture portion. So that's going to be actually running the camera itself and spitting that data to your hard drive. After we've collected that video file, we're going to use a program called Auto Stacker to stack the video file and select the best frames that we want to stack them up, and align everything beforehand. Auto Stacker does all that for us. After that, we will have a stacked image that looks kind of blurry. But we're going to use Registacks to sharpen that image using wavelets. And finally, for our final tweaks, we're going to use Photoshop to just kind of like, do some final cosmetic tweaks, get the color just the way that we like it, and maybe do a little bit of extra sharpening as well. And if we have time, I'll show you a tool that I've been playing with lately called Topaz Sharpen AI, which is actually using artificial intelligence to do the sharpening now, which is kind of cool. Sometimes it works, sometimes it doesn't. We'll see. All right, so when you're out there in the field, what do you got to do? So I'm just kind of like talk you through what you do when you're actually out there to capture this data, because that's the one thing that we can't do hands-on sitting in an office in front of Zoom. Oh, hey, Topaz Gigabit. Yeah, Topaz has some really cool stuff, Mauricio. They also have Topaz denoise that I use a lot too, which is also a cool tool. It costs some money, but definitely a good tool for the tool chest, absolutely. So when you're out there, first of all, ahead of time, before you go outside, figure out if it's worth going outside. So you want to find out what planets are near opposition right now. Right now, obviously, that's Mars. Mars is at opposition right now. That means that it's really close to Earth right now, really big. So this is the time to be imaging Mars. And in fact, tonight's a pretty good night. So when you're done, I hope a lot of you will have a chance to go out there and try this yourself, or at least look at Mars, because it doesn't get any better than it is tonight. Well, maybe once in a century, but it's pretty darn good tonight. You also want to check the seeing forecast, as well as cloudiness. So it's not enough just to have clear skies when you're going to be imaging planets. You want to make sure that the seeing conditions are good too. So my go-to source for that is Clear Dark Sky. Let's see if I can pull up my web browser here and we'll play it around.
We lost your desktop.
I think it's back. All right. So hopefully we're looking at the clear sky chart here. So if you just go to cleardarksky.com, this is kind of like the canonical place for seeing forecasts. And there are other places you can go to. Astrospheric has them too. But this is kind of the granddaddy of them all. So if you haven't seen this before, go to cleardarksky.com and find the weather station closest to you. For me, that's Sanford. But here's how you read it if you haven't seen this before. First of all, we have the cloud cover. And this doesn't really capture high clouds too well. So, there are better sources of cloud cover forecasts out there, but this is telling us that tonight, until 4 or 5 a.m. at least, it should not be cloudy. So, yay, that sounds good, right? Transparency, that's how hazy the atmosphere is. So this is more of an issue for deep sky imaging than for planetary. But, for now, it's definitely good enough for planetary imaging. It's above average, I'll take it. And the seeing is what's really important, right? So tonight, they're forecasting good seeing. So, yeah, good seeing. It might be worth going out and getting lucky, right? These seeing forecasts tend to be iffy on their accuracy. So there is a good chance that they're wrong and the seeing will actually be excellent. And there's also a good chance that they'll be wrong and the seeing will be terrible. That actually happened last night. They said it would be really good seeing last night. It wasn't. So take it with a grain of salt, but if they're saying that it's going to be poor seeing, you probably just want to stay inside. It's not worth going out there because you're not going to get results you're going to be happy with. And honestly, for good seeing, I'm not sure I'd go out even for that at this point because I've already gotten an image this year of Mars with excellent seeing. And I'm going to hold out for excellent seeing again before I try another one. Darkness, that'll tell you the moon's not up until, early in the morning. So it's going to be nice and dark too. Again, for planetary, doesn't matter. Oh yeah. You're not the only one, William Castro, who experienced bad seeing. I was talking to Derek earlier today too, and he was saying the same thing, that seeing was just god awful last night. So yeah, it's definitely not just you. Let's hope tonight's better, but the forecast is kind of iffy. Definitely, it's worth practicing, but you should temper your expectations. So you want to keep that in mind before you're deciding whether or not to even bother, right? So back to the slide. You decide to go out there, you decide that the seeing looks promising. The next thing you need to figure out is when is the meridian transit. Now this is more important than you might think. You're going to get much better results if you can photograph a planet when it's transiting the meridian. That's going to be its highest point as it traverses the night sky. And if I can find a way to pull up stellarium here, that's one cheap way to find out when that is. So let's just move ahead till nighttime and wait till Mars is up. Where are you, Mars? You should definitely be up somewhere. There's Mars, way up there. It's so high you don't need an atmospheric dispersion corrector. Just click on Mars, and somewhere in this wall of text will be the transit time. So at 1:15 a.m., if you really want the very best Mars image you can get tonight, you're gonna get up at 1 a.m. And this is what separates, the really great planetary imagers from the not so great planetary imagers. They wait, they make sure they're out there during the best conditions. Now, you really want to be within like plus or minus a half an hour of that transit time if you can, anyway at all. You're going to get the best results when this thing is the highest in the atmosphere. Why is that? Because again, it's all about the seeing. And the less atmosphere you're going through, the better the seeing's going to be, right? So, if I'm high in the sky, I'm not going through as much atmosphere. There's less atmosphere to mess up my image at that time. So it really is worth it to set yourself an alarm, get up at 1 a.m., set things up ahead of time, maybe leave it out there if you can. Get up at 1, go outside, push the button to capture the data, shut it off and go back to bed. That's what I do. You don't have to like totally disrupt your life with this, but you do want to make sure you're out there at the right time. And if 1 a.m. sounds terrible to you, okay, you can wait a month or two. Mars will still be pretty big in the sky for another month anyway, but it will be up at a more reasonable hour. So sometimes you have to kind of like make those life choices. All right, back to the slide here. Almost done with the slides, and then we're going to get back to some hands-on stuff. What the heck happened? All right, where were we? All right, so once you get out there and you get your, oh, really, Zoom? Really? You're going to freeze my video on me now? All right. My camera's overheating, it seems. Oh, hang on, guys. I think Zoom locked up on me. I have no idea if you can hear me because Zoom is doing nothing at the moment.
We can still hear you.
All right, that's a plus. And I think you're going to see me soon, too. There we are. We're back. Sorry about that, guys. All right, so you're out there. You're set up. Ahead of time, you want to get polar aligned as good as possible. As we'll see, that's going to save you a lot of hassle if you can get an accurate polar alignment later on. And you also want to collimate your scope, preferably near where the planet's going to be in the sky when you image it. Some say that it matters if you are actually on one side of the meridian or the other. If you're using a telescope that has mirror flop, you can actually have different collimation results on one side of the meridian versus the other. So best practice is to actually collimate your telescope while it's pointing in the part of the sky where your planet's going to be when you're imaging it, if at all possible. In practice, I find that my scope doesn't really need to do that, but excuse me, that is the best practice. So, it's important to get good at collimating your telescope. You want to practice that ahead of time because that really is critical to getting that extra resolution in your images. If your scope's out of collimation, you're not going to get those details in your final image. I use a product called Bob's Knobs that replaces the collimation screws on my secondary mirror so that, in the middle of the night when it's dark, I have to fiddle around with a screwdriver trying to find screws. I can just twist these knobs to adjust my collimation that way. And you always want to make sure that you can start off your collimation, without the Barlow lens. It's going to make it a little bit easier, but make sure you finish off where you're actually going through your Barlow and through your camera, looking at a live image. That's going to be the ultimate test as to whether things are actually collimated. And again, just to review how collimation works, you want to defocus your image. Turn that focuser knob until your stars look like this little picture here on the right. That's called the Airy discs. And when it's out of focus, what you should be seeing are these concentric circles. They should be perfectly concentric. So that dark circle in the middle should be concentric with all the other circles in that pattern. If it's kind of shifted off to the side in one direction, you're out of collimation. You need to adjust your collimation screws to do that. And the way to do that, the way that I do it, just stick your finger in front of the front of your telescope, pointing at one of the collimation screws. And you'll see the shadow of your finger in the image. So that will tell you if you want to push your collimation in that direction, that's the screw that you want to mess with, all right? You want to mess things up with that screw that you're pointing at. And if that's not the right screw, where your collimation is off by, try pointing at the other screw, and you'll see the shadow of your finger in the image there. And if that is actually pointing at the direction that your collimation is off by, that's the one that you want to mess with. So a little bit of a trick for trying to figure that out when you're out in the dark there. But it is essential to make sure that your collimation is spot on. If you're lucky, your scope will hold its collimation well, and you don't have to do that often, but you definitely want to check it before you start imaging. Also, make sure you get your telescope out there well ahead of time. You want to be out there, several hours ideally, so that your telescope has time to, adjust to the same temperature as the outside air. If your scope was sitting in a hot garage all day or something, or inside, it's going to take time for that hot air to dissipate and for the telescope to cool down. And until that happens, your seeing will be affected by these tube currents. So it's not really going to be so much about the atmosphere above you. You're creating your own terrible turbulence just within the tube of your telescope because it's cooling down and radiating heat all over the place. So give your scope some time to cool off before you start imaging. That's also very important. And we talked about waiting for transit time. That's super important. And finally, there are other sources of local seeing. Oh, William Castro asked, do I use a dew heater? I do. Only when I need it, though. So if you look at the weather forecast, if you go to like NWS, the National Weather Service website, and you look for the local forecast there, they have an hour-by-hour forecast graph that you can click on. And there it will show you the predicted temperature and the dew point. And if I see that the temperature is going to be approaching the dew point while I plan to be imaging, yeah, the dew heater goes on, because nothing's worse than your system dewing up when you've gotten up at 1 a.m. So yes, that might introduce some tube currents, but on an SET at least, the dew heater is going to be at the end of your tube, right? So it's not as bad as if your dew heater was down at the bottom radiating this heat up through the tube. At least it's up by the corrector plate, so that's not going to be as bad. Given the choice between the currents from the dew heater and dew, I'll take the currents. But yeah, another source of local seeing conditions is just what you're shooting over. So one of Bill Costring's secrets is that he goes out to a field to do all of his planetary imaging because he's going to be shooting over grass, which is not going to be radiating a lot of heat that got soaked up during the day. And I just froze again, so I think I'm going to switch cameras this time. Boy. Sorry about the technical glitches here. Of course, it's just par for the course. It's 2020, guys. Things go wrong. I'm sorry. Do I have the dew heater and the dew shield at the same time? Yes, I do. Ooh, no pun intended. It's Florida, guys. It's a war against dew here. It's always humid, so I double it up. Yeah, dew heater, dew shield. One is not enough. Absolutely. But as I was saying, Bill actually shoots over a field. And what you want to avoid is actually shooting over pavement or even worse, other houses or your house. The heat radiating off of those things is going to kill you. And, I post a lot of pretty pictures online, and a lot of people are like, gee, Frank, how do you get such good pictures from your driveway in suburbia? Well, the secret is my driveway is the southernmost driveway in my neighborhood. So typically, I'm not shooting over other houses or, other pavement. I'm just shooting over this conservation land to the south of me. So there's nothing to mess up my seeing there. So that's my little secret. And finally, just before you're about to push the button, make sure you're focused. So take time to get the best focus you can before you start capturing your images. And this is tricky. If you got iffy seeing, it's very hard to manually focus these planets. Now you want to be focusing on the features of the planet itself. It's not going to be good enough to go focus on a star like you would normally. You want to focus on the planet because you're trying to capture even finer details than you would be getting in deep sky imaging. So if you're looking at Saturn, focus on that gap between the rings. Try to get that as sharp and distinct as you can before you start imaging. If you're shooting Jupiter, look at the cloud bands, look at the great red spot. Get those features as crisp as possible before you start capturing. Mars, same thing, the dark features, the polar ice cap, anything you can use on the planet itself to dial that focus in. And take the time to get it right. It can be a frustrating experience because every time you touch that focus knob, things are going to start jiggling and it takes some time to settle down again. But You just got to work through it. Having a motorized focuser can help because it won't jiggle as much when it changes the focus. I like the JMI Motofocus myself. The other ones feel kind of cheap, but you know, they're better than nothing. So if you want to do that, that can help a little bit too. But always check your focus before capturing, and it's not enough to focus early in the evening and assume it's going to stay that way. You'll find that the focus changes as the night goes on, sometimes dramatically. So always, always, always check your focus right before you start imaging. And that's it for the slides. Ooh. And I froze again. That's awesome. Hang on. All right, so it's time to stop my screen sharing for now. And before we dive into some hands-on fun here, does anyone have any questions that we didn't address in the chat? Feel free to unmute yourself if you want to yammer. No? Everyone's good? All right, we'll move on. So I'm going to share my screen again, and I'm going to show you quickly what fire capture looks like. And after that, we'll go hands-on and start processing some data. Sound good? So let me share my screen again. And let's open up fire capture. So obviously I'm not really going to capture anything because I'm not outside, but fire capture has a neat thing called the dummy camera. So I'm going to start up fire capture here. Hopefully you guys can see it. And if you were doing this for real, you would select your camera. For me, that's a ZWO. And once you do that, once you don't have to do it again. But for the purpose of illustration, I'm going to click on dummy cam, which is a way to play around without actually having a camera attached. All right, so this is what fire capture looks like when you're actually running it out in the field. And I'm assuming that you've plugged in your camera through your USB 3 port on your laptop. Very important. That's going to be a port with a little blue line inside the port. So that's how you can identify a USB 3 port. It has a blue line inside. Make sure you're using that. And this is what you'll see if you've already focused and trained your scope on Mars. Hopefully it's not as jittery as this, but more or less this is what you would see. Actually, what you would see is more like this at 100%. So what do? Well, first of all, make sure that you start by selecting the appropriate planet here. So under the Capture tab over here, you can select what planet you want. And this will give you some helpful presets to start from that makes sense. If you're using a color camera, this is just going to say RGB instead of luminance. And that's pretty much it. Now, for Mars, you need to think about how long you can get away with photographing this before rotation starts to mess up your image. Now, Mars, as you might know, rotates at pretty much the same rate as the Earth. So it's going at a pretty good clip. It turns out you don't really want to go more than like 3 minutes at one time capturing Mars. That's also the same rule for Jupiter, by the way. So I'm going to make sure that I'm not going to capture for more than 3 minutes. If I click on no limit here, I can set a limit here for 180 seconds, and that's going to be more appropriate for Mars. You can see we're capturing in that mysterious SER movie format. You can also change that to AVI if you want, but hey, let's go with SER, why not? The next thing you want to do is dial in the gain and exposure. Now remember, the whole point of lucky imaging is to get that exposure as low as possible. You want to freeze the seeing and capture these moments in time when the seeing is good. So for right now, where Mars is at opposition and it's super incredibly, ridiculously, ludicrously bright in the sky, you can actually go down to like 10 milliseconds, maybe even 5 if your system can support it. And in this dummy cam, it's not actually going to do anything to the image, but that's basically where you want to be for Mars. Now, if Mars was not at opposition and it was on the other side of the solar system, you'd probably have to bump that up a little bit higher to get enough exposure to get a good image. So remember, what you see in the camera is roughly what you're going to see in your finished product. If you're seeing a really grainy, lousy image in this preview here, you're going to get a grainy, lousy video when you're done. So try to make this thing look good, If you're using a color camera, the one button you're going to use here is the debayer. I think it's this one here. So again, it's not going to do anything in my dummy camera, but that would actually give you a color image in the preview screen. So there's a lot of bells and whistles and features in fire capture. That's pretty much the only one you need to know about, really. That's what will give you a color image. So if you want a pretty color picture and you just want to see how it looks, or even just use this for outreach out in the field, that's how you can get a color image of Mars or whatever you're looking at. Then you want to play with the gain. So typically you don't want that all the way up. That's going to be pushing the gain too far for your camera, getting all sorts of nasty noise. Somewhere in the middle is probably about right. Again, it depends on your camera, but I try to keep it in the middle. you'll find that when you're actually using this for real, there'll be a little bit of a blue outline here that kind of tells you what the safe range is for your gain. So make sure you stay within that. So again, you want to get that exposure as low as you can. Sometimes it's going to mean boosting the gain up a little bit, but it's kind of a delicate dance. At the end of the day, you want the gain and the exposure set in such a way that the exposure is as short as you can get away with, and the histogram here is about 2/3, okay? Some people say 1/2, I say 2/3. Anywhere in between is probably okay. Just make sure you're not saturating any of the color bands here. For Mars in particular, that red channel can really get out of control. So if you find that the histogram is like pegging itself out over here, you're gonna have to either increase the exposure or reduce your gain to get that histogram down where it belongs. So just like with any form of photography, you wanna pay attention to your histogram, make sure that it's around 2/3 here, and that way you'll have a nicely exposed image and you're not gonna lose any data due to clipping. And you'll also take full advantage of the bit depth that you have available too. Really, that's why I go for 2/3 instead of 1/2. These are fundamentally 8-bit cameras that you're dealing with per color channel. That's not a lot of color depth. So you wanna make sure you're taking as much advantage of the bits that you have by getting that, getting that histogram up here somewhere, but not to the point where you have to worry about a clipping. So kind of a delicate dance there. And you need to do that in such a way that the exposure is as short as possible. Make sense, guys? All right, cool. So once you've got everything dialed in and you like it, just hit this little red button here to record it, and this is gonna let it run for 180 seconds. It will automatically stop if you set that limit of 180 seconds. When it's done, it will prompt you to save that SER video file to disk, and you're done. You can go back to bed. Although, typically if I've taken the trouble of getting up, I usually try a few different variations on the settings just so that I have different things to play with when I start processing the data. You might want to try different combinations of gain and exposure just to see which works best and have that in your back pocket. Also, seeing can change throughout the night. So sometimes you'll notice that even with the same settings, a recording that you took, 10 minutes before another one looks a lot better for whatever reason. So, it makes sense to take, a few different exposures if you can, just to have them to pick from. Oh, another thing I forgot to mention too, before you start capturing, make sure you draw a little box around the planet like that, okay? And set that to your new image size. That is important because you need to minimize the amount of data that you're transferring across the wire in order to get that to come down reliably. So the smaller you can make that image, the better. That's going to result in less data being pushed through your system and through your hard drive, and you'll be less likely to have throughput issues as a result. If that image is too big, you're going to run into this really annoying problem. Let's see if I can actually take a recording here. Yeah, it's not showing it to me, unfortunately. But when you're really recording, we'll have a display of 3 numbers up here. And one will be like the frame rate that you're trying to get, and the other one will be, the number of frames that you've actually captured. And the thing that you hate the most is when that number stops moving. That means that your bus has choked up, your hard drive is choked up, and you're not actually capturing any data. So when that happens, try to make that window smaller. That might help. I've also found that just quitting fire capture and restarting it again sometimes will, get things back into a better state where it can actually capture more reliably. So if you're getting really frustrated, try just quitting it and starting it over again. That works 80% of the time, actually. But again, this gets back to why it's important to have a good polar alignment. If you're not really tracking this thing well, you're going to need a bigger square, or else it's going to keep drifting out of that square on you. So having a good polar alignment pays off. Now, there are some fancy features in fire capture that will automatically track it for you and even automatically guide your scope, but they require, pretty careful calibration ahead of time. And if you're like me, you just pop your camera on without thinking about what direction it is, that's not going to work out so well. So it's a lot easier to just get your polar alignment good from the get-go, so you don't have to worry about it. All right, so imagine that at this point we have captured a SCR file for Mars. And I already did. I gave it to you already. So let me quit fire capture here. All right, so we've actually captured our image at this point. We've gone back inside and we're ready to start processing. So here's where it gets fun, guys. Wow, I totally lost my video. Remind me to turn this camera in. All right, so somewhere you should have that SCR file that we gave to you ahead of time. If not, just watch, it's cool. You can do it later if you want to. First step is to open up AutoStackered. So if you installed AutoStackered earlier, all you had to do was unzip that file and you should see something like this. So time to follow along if you want to. Go ahead and open up AutoStacker on your PC. And you should see something like this. So it's actually pretty easy to use. There's just a lot of like little tips and tricks that you need to know to get the best results out of it. Now, AutoStacker is what we're going to be using in order to actually align every frame of our video there and identify the best frames in that video, discard the ones that suck, and stack the ones that don't suck. All right, so that's all we're trying to do at this point with AutoStacker. And wow, is there any way for me to like change my camera? I'm sorry, guys, like video keeps going nuts on me here. All right, anyway, the first step, they conveniently number them for you here in the UI. So go to the left-hand screen here, and we're gonna click on the Open button. And we want to identify that SCR file that you downloaded earlier, that big, 1.88 gigabyte monster. And you should see the video over here on the right-hand side, all right? I'm gonna take it kind of slow here so you guys can follow along if you want to. All right, so if we go to this frame slider up here, you can actually get a little preview of what it looks like. So this is the actual video file here with some really basic alignment applied to it, just to get the centroid of the planet in the same spot. So you can see the seeing was actually pretty darn good this night. Yeah, I mean, you can actually see some features on there, and it looks pretty promising. The exposure looks good, nothing's blown out, so looks like good data. So our challenge here is to find the best data and actually align things better. Now, the magic of AutoStacker is that can I do what we call multi-point alignment. So it's not just going to align things based on the center of this circle here. It's actually going to look at individual features of the planet itself and align those, within the disk of the planet. So even as the seeing is wobbling across the disk of the planet, it can correct for that as well. That's kind of the power of AutoStacker. So there's a few ways you can set up those alignment points. The easy way is to just select an alignment point size. And for something like Mars, where it's a relatively small planet, you probably want to go with the smallest setting here of 24. If I was doing Jupiter, I might go to 48. And if you want to cheat, you can just say, place AP grid, and it will automatically place a bunch of alignment points across your planet there for you automatically. And this is a perfectly reasonable thing to do, guys. AutoStacker is smart enough to throw away alignment points that don't have enough contrast within them to work with. So it's okay to just do this. But if you really want to, be a perfectionist, you would do part of this process by hand. By the way, make sure multi-scale is enabled here. That's going to actually put a variety of scales of alignment points across this so that even if you don't have enough contrast within a small alignment point, you might get enough contrast in a larger one for it to work with. So very important to use that. So I'm going to clear this out and show you a different way to do it. I'm just going to hit this clear button here. And what I'm going to do is place some of these by hand. So what you want to do, if you're going to do this the hard way, is to pick this smallest alignment point size and place that along areas of high contrast, because that's where it's going to work. So for example, along the polar cap, place a couple there. So go ahead and follow along with me guys here if you want to, and place some manual alignment points. And you want to go across these areas of high contrast. So you can see like around the edges of these, what do they call them, planetias? I don't know. I'm not really up on my planetary science. But I'm looking for areas of high contrast where these alignment points have something to lock onto, okay? So something like that probably works if you're following along. But we don't just want those alignment points. We want some bigger ones too to capture larger features as well. So what I'm going to do is select 48. That's going to be the next size up. And I'm going to let it do multi-scale and place that alignment grid on top of it. Now, we're going to make sure that replace is off because I don't want to replace the points that I just put on there. I want to add to them. So I'm going to set that to 48, the next size up, and say place AP grid. And that will place 48 and up alignment points on top of those ones that I set by hand. So in principle, this should give you the best results. So now what? Next step is to actually analyze the video so it can actually tell us what are the best frames to keep. So let's go through some of the settings here. These are all defaults, so you shouldn't have to play with it. We're obviously dealing with a planet here. If you were like doing the moon, like the surface of the moon, you would select surface instead of planet, but Mars is a planet, so we're going to be imaging a planet. Dynamic background, you just want to keep that on. There's no reason to turn that off. And the quality estimator, there used to be more choices here. Today, there's only Laplace, so I'm not sure why you would not want it. So just keep the defaults here. Nose robust 5 is perfectly reasonable. If you do have really noisy data because your gain was set too high, that might be a case where you want to like increase that a little bit, but at the end of the day, it doesn't make much of a difference, to be honest. Click Analyze, and we'll wait for it to analyze the video. And how long this takes will depend on how good your PC is. So mine just finished, but if yours is still running, please holler before I continue. I don't want to leave anyone behind. Again, feel free to unmute and just yell at me. All right, we'll move on. All right, so we have this quality graph here that wasn't here before. So it's important to understand how to read this thing. So what this is doing is telling you the quality of each frame over time in the video. So you can see that the seeing, as I recorded this over 3 minutes, actually got better. So over time, the seeing was improving, which is interesting because I actually shot this right before the meridian transit. So as it was getting closer to the meridian, the seeing was just getting better and better. This really drives home the fact that you really want to wait for that meridian transit if you can. It's going to give you the best conditions. So it started out kind of bad. We had this like little spurt of good seeing, and then it got bad again. And then it got better again and kind of fluctuated a little bit. But by and large, the second 2/3 or so of this video were pretty darn good. So that's good. That's encouraging, right? Now, what about this green line? The green line is showing you what that quality graph would look like if it were sorted by quality. So if I put my best frames first and my worst frames last, that's what that curve would look like, all right? Now, we're going to try to use this information to figure out which frames do I want to keep when I stack and which ones do I want to discard. And the secret to this that hardly anyone knows is you want to find the point where this green line intersects that blue 50% line. That's going to give you the point where your frames are above, they're in the best half of the quality that you have. And to understand that more intuitively, you can see that most of these frames were above that 50% mark, right? We had some really lousy ones that made for bad frames, but we want all these good ones that are above that 50% line. And to do that, we're going to hit the Control key and click at that point right where the green line intersects the 50%. So again, hold down Control and hit click. All right. And if you see what that did, it automatically populated this number here, the frame percentage to stack. So based on that point, we're going to only stack 63% of the best frames in our video. All right, so that set that for us automatically. A lot of people kind of guess at what to set that to. There's a lot of mythology around this. Some people are like, fewer good frames are better. Some people are like, I want all the frames. Some people are like, I always use 50%. Some people always use 20%. No, that's wrong. This is the right way to do it. The principal way to set that is to find that intersection point, right? Control click on it, and it will automatically set that to the ideal setting. So there's a little trick for you that a lot of people don't know. Now we're almost ready to stack at this point. So you can normalize the stack, just to get it at a reasonable brightness if you want to. I'm not going to do that because I'm going to do that in Photoshop later on. So the less processing I can do at this point, the better. I'm also going to sharpen later on with Registacks and Photoshop, so I don't want it to sharpen for me. I just want it to stack. I do want RGB align. This is important, guys, because it's off by default. This will automatically align the red, green, and blue channels to each other in a very good way. And that will actually go a long way toward correcting for any atmospheric dispersion that might be going on due to refraction. And if you want to save it within its own dedicated folder name, cool, you can do that. The last thing to worry about is drizzle. So this kind of depends on how good your computer is. If you have a pretty beefy computer, you probably want that set to 1.5x. What drizzle does is it kind of subsamples each pixel throughout the stack to actually extract more resolution than the camera has. So if you're actually undersampling and there's more resolution available to you from the seeing conditions than your camera was able to capture, it can actually reconstruct some of that additional resolution by increasing the size of the final image by 1.5x and subsampling within pixels to get that extra data. So if you have a beefy computer, there's really no reason not to do that, because it's going to give you a bigger image that's going to be a little bit more social media friendly. And it has the potential of pulling out more detail that you wouldn't have gotten otherwise. So I always drizzle at 1.5x. 3.0x is just overkill. There's no reason to do that, but 1.5 is a good sweet spot. If, however, your computer is not the latest and greatest, you might want to keep that off just to keep the stacking times reasonable. So once you've done that, you can just click on the stack button, and that will start the long process of stacking that 63% of the frames together. So I'm going to go ahead and click that. And that generally takes about 5 minutes or so. So while we're waiting for that to process, and while you're waiting for it to process, if you're following along at home, this would be a good time to stop and take any questions, or go get a drink, or just stop listening to me for a few minutes, because I've been talking a lot. So guys, if you're following along, just holler when it's done. Like I said, it's going to take about 5 minutes. And if you do have any questions, feel free to unmute and holler at me. Otherwise, I'll give you 5 minutes of blissful silence. And if you're not following along,
can you hear me there?
I can.
So if I were to try this with, you know, because I don't have that kind of, I don't have the kind of camera you have where it's like the glorified webcam, right?
Yeah.
But if I were to try this by, say, shooting a video on just like a Canon Rebel, would you be able to take would you be able to upload like a video to a software like this and then extract those frames?
They can't accept AVI format. So if you can get it in an AVI or convert it to an AVI, in theory you could. It really comes down to how fast you can capture that video. I know DSLRs, yeah, I've never gotten more than 30 frames per second out of one myself, but that might be enough. Yeah. So.
Yeah. Well, just to get started, right? You know.
Yeah, it's worth a shot. I've never done it myself, but in theory, it should be possible. Yeah.
Okay. Thank you.
Yep. And what kind of scope would you be using with that, Mauricio?
Well, at the moment, this is actually related to my comment before about the Barlow, because truthfully, I haven't really done much astrophotography through the actual telescope. I've done almost all of the stuff that that I've been posting or sharing has actually been captured through a telephoto lens on my camera, which I have mounted on top of an equatorial,
right,
that I use for guidance, right? But I'm getting ready to kind of take the next step and start imaging through a telescope. And the first problem that I encountered was that my on my camera, literally on the reflector, can't get close enough to the secondary mirror to focus, and that's when I realized, oh, well, maybe if I use a Barlow, it can focus, and it does, right? But I noticed the image is kind of soft, so I was thinking like, oh, maybe the Barlow messes it up. So I was actually thinking about trying to use a Celestron 8 SE that I have, but instead of using the mount that it normally uses, but using this this astrophotography mount that I have on that, and using that. So that's what I was gonna try.
Yeah, that sounds like a good idea. You'll find that the 8SC, has much more forgiving back focus, so you can actually put a lot of junk on the back of it and still focus effectively.
Yeah, I noticed that. I noticed that, and that's why I wanted to give that a shot. So I'm gonna give that a try.
Yep. And if the video thing doesn't work out, I mean, you could just take a few really fast snapshots, just make sure the exposure time is super low, and you might get a few lucky shots that way too.
I have actually, I actually did try that a few times. I got a few just kind of single frames of Jupiter and that way, and it wasn't, you know, it wasn't too bad. I don't think I was able to really stack them properly, because so far most of the stacking I've done has been kind of like deep sky objects. So I'm still figuring out the process for processing those images for Planetary, but it's just trial and error, you know.
Yeah. Yeah, Planetary is a different beast. So, you know, the tricks I work on the sky don't work with planets.
Yeah, totally different. So, but this is like super interesting, and I love the photos that you've been posting of Mars. Are just mind blowing, man. Crazy.
Thanks. Yeah. Well, this is actually the raw data behind one of them. So when we're done here, we should get something really nice when we're done.
All right, Frank. Thank you.
All right, 70%. Apparently my PC cannot stack images and run video at the same time, but hopefully y'all can hear me. So yeah, if you guys want to, you know, grab a bite to eat, take a little bio break, this might be a good time. I think we're going to be about still a few more minutes before people are done stacking here, so bear with us.
Frank, are you still there?
Yeah.
You missed my comment on the chat about focus difference between a star and focusing on a planet.
I did.
Why do you suppose that is?
I could make up an answer. I don't know. That's actually a trick something I learned from Damian Peach. I took a lot of his online courses, and that's one of his tips. But I found that it's right. You know, I do find that if I focus on a star or even a moon of one of these planets, when I go and actually look at the planet itself, it's out of focus. So I don't know why. I mean, maybe the actual
I have to agree with you. I've been very disgusted at the response I got from imaging a planet ever after having focused on a star.
Mm-hmm.
But I just cannot understand why it would make such a difference.
My experience has been the same.
I understand that a star is farther away than a planet is, but gee whiz, I was also under the impression that once you get so far, the difference between infinity is and infinity is nothing. I mean,
right. Yeah, I don't get it either. I mean, like in theory, you should be able to focus to infinity and like get perfect pictures of anything in the sky, right? But we know that's not how it works even with deep sky objects. Like there's something to it. I guess it's like correcting for the atmosphere, maybe. I don't know. And maybe planets just punch through the atmosphere better because they're brighter. I don't know. I'm making this up, but there's something for sure.
Yeah, well, it's just whatever your thoughts might be. It would be nice if we had an absolute response on it, but if you don't have it, you don't.
I'm afraid I know.
This is Bill Castro. I know some optics engineer type. I can ask them. I know one is a point source, the other is extended object. You know, it's got width to it. Then you've got atmospherics going on, but my background is electrical engineering, so
oh, me too.
I don't know the details on that. But one thing I wanted to ask was, is there a rule of thumb on pixel size and focal lengths for Planetary?
Yes.
I thought I read something way back, but I can't remember.
Yeah, it's supposedly something like, what was the number anyways? 5 times the pixel pitch is the focal ratio that you need. So if your pixel size is 5 micrometers and you then that means that 5 times the 5 means you should be shooting in the neighborhood, not exactly, but in the neighborhood of an F-25.
Yeah, that sounds right. And you know, I'm just gonna turn my video off because I give up.
Is that F-25? Is there a certain arc second per pixel number?
The F-25 is the focal ratio of your telescope.
Yeah. Okay.
Okay, so if you've got a 2,500 millimeter telescope in a Schmidt-Cassegrain, then you want to double. Yeah, what am I saying? If you've got a Schmidt-Cassegrain that's an F10, then you want a Barlow of 2.5 to bring it up to a F-25.
Yeah, that sounds right.
But that's not. But then you don't care what the pixel size is on your camera?
Well, no, I started out saying if you have a 5 micron pixel,
okay,
5 times that is 25. So the F ratio that you want to be shooting at would be an F-25.
Okay, gotcha.
And just for reference, the camera I use is about 3 microns. And yeah, it's a F10 native with a 2.5x Barlow. You know, most people don't think about it too much because they just kind of like use the same setup that everybody else uses for planetary imaging, which is typically a Celestron SCT that's F10 with a 2.5x Barlow and an ASI 224 MC or the monochrome equivalent. But yeah, for that kind of an optical system, you want around a 3.5 micron pixel size.
What I've been finding is I think what they call the pixel pitch in the image, how many arc seconds per pixel, it generally comes out to be about 0.1 arc seconds per pixel.
Yeah, that sounds right.
Okay.
Which is crazy, right? Because like seeing is usually like 2 arc seconds, right? So how the heck are we getting like 0.1 arc second detail? But somehow we.
That's where that lucky imaging comes in.
But I've always found that like interesting because, you know, it kind of like flies in the face of what the math is telling you what should be possible. You know, sometimes you have to take these numbers with a grain of salt. Looks like I missed a question from Robert Scott as well. You mentioned a big fast hard drive. How big? Did I mean SSD? SSDs tend to be really fast for reads, but writes, I'm not so sure. You want something that can write really quickly. And the other problem with SSD is that it's hard to get really big ones. So with this file we're dealing with right here, this is a single capture from 3 minutes, and there's like almost 2 gigabytes of data here. And I know that when Bill Costring goes out, he like gathers terabytes throughout the night. So good luck finding a terabyte SSD. So you know, you probably want to get a hard drive that just has a really fast write time. So I forget what the technical term is for that, but yeah, SSD probably isn't going to have enough space for you. So you just want the fastest hard drive you can get for writes. All right, so my stacking is finished here. Is anyone else still going? Feel free to chime in. I'm happy to wait. You are? All right. How far is it for you? What percent?
Oh, gee, I'm into the image stacking at 40%.
Okay, you got a ways to go still. Are you drizzling?
Yeah.
Yep, that's why it's so slow. But
I'm partly cloudy.
Ooh.
That was a good one.
You can go ahead and continue as far as I'm concerned, though.
That, you know, the best Bob puns are the ones that take 10 seconds to sink in. But, you got me. All right. Well, we'll get.
I ran the stack earlier, and I've got a result without the drizzle.
Well, what's it at now? We're making progress.
41%.
Not so much. Maybe we should continue.
Not so much. I thought I had a pretty decent laptop here, but 4-core and a i7 processor.
Yeah, that ain't bad. I'm actually on a desktop.
And I have my whole hard drive is solid state, so I thought it would be running, you know, pretty damn fast.
Yeah, I mean, that's another point I should bring up too. I'm actually processing this on a desktop PC, so
yeah,
sometimes you want to transfer the data over, and it's a little bit more efficient that way. I also find that it's a lot easier to tweak the image itself when you're on a real monitor and not on a laptop. So, yet another reason to move it over to a bigger machine if you can.
Yeah, I used to have that convenience of being able to run a desktop in the house, but I don't have the space for it anymore.
Yep, I hear you. I'm looking to simplify my office as well. Well, anyone else? Go ahead.
In fact, I'm going to have to take a 10-minute break to walk the dog.
Okay.
I'll be back in a little bit.
Well, why don't we all take a 10-minute break then, guys? We shall reconvene at 7:20. Sound good?
Just one quick question. It's Bill again.
Yeah, I'll
has anybody had any luck with a point and shoot camera using that in video mode?
Not that I've heard of. Mauricio was talking about trying it, and I don't know why it wouldn't work. My concern would be, can it actually capture fast enough and just have enough storage space to actually pull this off? My guess would be that you could capture maybe a few seconds of data that way, and it wouldn't really be, the exposure length that you'd want necessarily. But it might be better than nothing. I don't know. The thing is, when I'm actually out there collecting data for this stuff, I'm looking to get tens of thousands of frames of data. Like that's when the stuff's going to average out. So if you're going to be like taking a bunch of snapshots with a point and shoot, and you have like 20 of them, I don't think the math is really going to work out. As you'll see in the next step, when we actually go to sharpen this stuff, you're going to be starting with kind of a blurry stacked image, but it's blurred in such a way that everything averaged out to be this really nice Gaussian distribution that we can reconstruct with wavelets. Whereas if you just have 30 or 40 frames, you're probably not going to have enough information to do that, would be my guess.
Okay.
But I certainly will not stop you or Mauricio from trying. I'd be very, very interested to see what kind of results you get from that. And let's see.
We're on break. I'm going to take my telescope outside.
All right. Yeah. We'll
get it ready.
Awesome. Yeah, it's a good night. So go get a line while it's still twilight. Like I said, we'll come back at 7:20.
So since we're focusing on planetary imaging, I was wondering if anyone has seen this this kind of new telescope concept for imaging like exoplanets using the sun's gravitational lensing. I don't know if anyone has heard anything about that.
Yeah, I saw a headline to that effect, but I didn't really read it.
I saw a video on YouTube about it. I forget the YouTube channel, but the guy always does a really good job with his. He gets into really detailed info, and you can just tell he really knows what he's talking about. But basically, the idea is to send out a series of telescopes to. It's like a crazy distance, though. It's like 600 astronomical units.
Oh yeah. I have heard about that. That's an awesome. Yeah.
Yeah, and that's like the stretch of space where the way the sun kind of gravitationally lenses light. That's like the focal point, right?
Right.
So once you get the scopes out there, you can start imaging, and the concept for the scopes is promising something like every pixel is, I can't remember the exact numbers, but it's like every pixel is supposed to be like 50 kilometers on the planet. So we're talking about like insane levels of detail for exoplanets. Really just an exciting concept. unfortunately, it's like it's going to take the first generation of telescopes so long to get out there that I think we're looking at like if they were to start the project today, I don't think we'd get the results until like 2100 or something. It's just like one of those crazy projects.
Yeah, but I think I remember reading that there are some concrete plans of doing it. You know, some people are actually trying to make this happen for real. And yeah, you're basically talking about like a solar system sized telescope. I mean, it's an awesome idea.
Yeah, and it's like once you get the first kind of generation out there, you know, you keep sending them out like year after year, and so it's like you don't have to wait as long for the next. You just kind of keep on sending them out, and you have this constant stream of exoplanet imaging.
Yeah.
So that sounds like that's it sounds like that's what the future of, you know, exoplanet imaging is going to be. It's pretty cool. Absolutely,
yeah. And if there's anything interesting going on these exoplanets, that's one way to see them, you know. It's very exciting times. So while we're making idle chit chat, what do you think the odds are of discovering life of any form on another planet within our lifetimes? No one's going to take me up on that.
Well, I mean, the stuff with Venus is, like, do you mean in our solar system?
Or in an exoplanet someday.
I mean, I'm excited about what's going on in the solar system alone, right? Because especially with the phosphine discovery on Venus, that's a really exciting development, you know, especially after the planet had been written off as uninhabitable. So I don't know, I'm feeling good that, like, I feel like if the life is in our solar system, I feel good about making that discovery in my lifetime, right? Like, if it's there, I feel like it could happen in my lifetime.
Well, I think what's changed is that we're actually getting serious about looking for it now. You know, it used to be kind of like, you know, the kiss of death for a scientist to even suggest that they're going to look for alien life. But, you know, it's more of a mainstream idea right now. So we can actually, like, send out probes and actually look for it for once. Who knows what we'll find. Exciting times.
Yeah, that does mark a really big change in our mentality, right? Because it used to be that a lot of the things we're talking about doing today were kind of like this distant dream, you know. It was, like you said, it was almost taboo to talk about it. And if you go on YouTube, you can actually see some really interesting videos where, like, there's one I saw where it was like it was the 60s, and they were going around interviewing people, asking them if they thought there was extraterrestrial life. And it's really interesting to see what people had to say about it back then versus today, you know. And there's a lot of people that were like, yeah, you know, definitely. And then there was a lot of people that were like, absolutely not, like, nowhere in the universe. And they're saying this with such a certainty, you know, that I feel like today would be a lot less common.
Yeah. Yeah, I've been reading a book lately called, what's it, Beyond the Edge of Time, I think, by Brian Greene. And he goes into a lot of the, it's his newest book. It's a good one, and it really gets into, you know, kind of like the chemistry and the physics behind the emergence of life, and how it's almost a possibly an inevitable result of just how, you know, energy and entropy works. You know, like, if you just, like, pump sunlight into the right environment, how do you not get life is kind of his argument. So,
right.
You know,
yeah, that the inevitability of it.
Right. So I guess we'll find out.
Yeah. I think my favorite contribution from Brian Greene is personally is he explains the concept of past, present, and future really well, as existing in a, like, the past is not gone, the future has already happened, you know, the relativity. He did a really great job explaining that.
Absolutely. Yeah, he had a PBS series at one point too for the Fabric of the Cosmos, I think it was.
I think that might have been
good TV series too. Yeah, he's one of those rare science communicators who really knows what he's talking about, you know. A lot of them have kind of been out of the field for a while and doing too many TV shows, but Brian Green is the real deal.
Well, I'm back. My stacking hasn't finished, but like I was trying to say before I left, I worked on this earlier today, and I've already got a stack, not drizzled, but I've got a stack that I can play with.
All right, we can go with that. So if you're not drizzling, that might mean that you're going to be using different wavelets than I'll be using, because you're going to have smaller features to work with. But you already know how that works to some extent, so you'll figure it out. And it is 7:20. I promise we'll be getting back going, so let's get back going, because I want to get you guys out of here and doing some imaging. It's getting darker and darker as minutes go by. So if you're stacking finished, you should see in your documents, alongside wherever you save that SER file, should be an AS_P something folder. And that is autostackered_P percentage of how many frames you stacked. So for me, I stacked 63% of the frames, so that's going to be P63 for me. For you, it might be a slightly different folder name, but go find that folder, and that's where your stacked image is going to be. Now, before we open that up, you can open it up in an image editor if you want to, but we're going to open it up using Registax. So hopefully you already installed Registax, so we can actually close out of AutoStacker at this point. We're done with it. And I'm going to open up Registax. And this is what we're going to be using for wavelet sharpening. So now that it's open, I'm going to hit select. And I'm going to select that image that we just stacked. So again, go find that AS_ whatever it is folder alongside your SER file and open that up in Registax. You'll see a pop-up that says stretch intensity levels. Sure, why not? I'll say yes. All right, so you should be seeing a somewhat blurry picture of Mars on your screen right now. If anyone does not, please holler and I'll wait for you. We're good? Okay. Moving on. So this is where it gets fun. So we're going to take this blurry mess and make it a not blurry mess. And to do that, we need to understand how wavelets work. So we're going to be using something called wavelet sharpening. Now you'll see here that we have basically 6 layers of wavelets. And the way this works is that as we go higher and higher in the numbers here, we're going to be sharpening larger and larger features on the planet. So wavelet level 6 is going to be sharpening features that are probably larger than anything that's in this image. And wavelet layer 1 will be sharpening very small features, probably on the order of noise grains. So in practice, we're going to be focusing our attention around the 2, 3, and 4 level for most images. So 3 is going to be kind of like the sweet spot of these like medium range features. 2 will get you some finer details, and 4 will get you some larger features sharpened as well. The best way to get a feel as to what these things really do is to just play with them. So let's start by just cranking up number 3 all the way. And you can see right away we've got a lot more detail in this image than we had to begin with. And that's showing you like kind of the level of features that it's going to be sharpening. Now let's do the same thing for level 2. Turn that up all the way. Wow, that really popped now, right? So we're getting even finer details. And if you want to understand the difference between 2 and 3, we can temporarily deselect 3 here by hitting that checkbox. And that's just going to show you the effect of layer 2. I can put 3 back on and turn off 2, and that's going to show you the effect of layer 3. So it's kind of a subtle thing. It's a little bit easier to see if you blow this up. There's a show full image checkbox here that'll blow that up for you if you want to. All right, so let's turn up 4, see what that does. Does that make things better or worse? I think it's a little bit better. All right, so that brought in some even bigger features. You're gonna find though that 5 and 6 don't do much. So yeah, the rule of thumb with any image processing is that less is more. You know, you don't want to over sharpen things, you don't want to over process things. So if you find that these sliders aren't really having a visible difference in the image, don't use them, leave them down. Let's try 1. Like I said, it's gonna really be tackling noise more than anything. And yeah, let's just make it noisier. So let's put that back down to 1.0. It doesn't have to be exact. All right, so now we can start fine-tuning things. So everyone has their own kind of approach to sharpening in Registax. This is mine. I start with linear and Gaussian for the default settings here. So there are different ways of going about this, but this is what I start with. I do not link them because I like to control these individually. So what I usually do is I start by cranking the levels that actually affect the image all the way up. And this basically tells you how much I'm blending in that wavelet sharpening into the final image. Now we can see that one artifact that we're dealing with right now is this sort of noise around the edge of Mars here. So by sharpening, sometimes you end up producing noise as a byproduct, but we can correct for that. So if I go to layer 1, remember that's going to be the really fine details like noise. I can bump up the denoise on this. And this doesn't matter what that slider is set to, it's going to do the same thing. So let's go ahead and crank up the denoise on layer 1. We're going to click that a few times until I see that noise around the edge disappear. So for me, that's around 0.2, maybe 0.25 to be safe. All right, so that noise pattern is gone now. All right, so the sharpening is looking better than I started off with, but I can probably push this even further. So let's go to layer 3, and we're going to crank up the sharpening beyond 0.1. So this is going to make the sharpening more aggressive on wavelet level 3. I'll take that up, and I'm just going to keep on increasing this until it starts to look silly. So you don't want to over sharpen. Like if it starts to look unnatural, you've gone too far, and it's real easy to go too far. Right there is pretty close to going too far. Things that I'm looking at, do these boundaries look too sharply defined? You know, does it look like artificial levels of detail? There's these weird like dimples showing up here that I'm not sure are really real. I think those are kind of exaggerated. And also pay attention to the polar cap. If that starts to get washed out or too sharp, you've gone too far. So we're just going to experiment with that. Let's do the same thing on level 2. See if we can bump that up a little bit more. Again, I'm just going to go until it starts to look silly, which is about there. So for both of these, I think I've gone one step too far. I'm going to back this down to 0.14 and this down to 1.2. All right. Now keep in mind this is blown up. So, you know, you're not going to get, it's going to look better at its normal size. Let's uncheck show full image. And you can see that already we've got a pretty nice image of Mars here to work with. So already I'd be pretty darn happy with that result. All right, now if anyone else is still fiddling, let me know and I'll give you some time to catch up and experiment because this is largely a game of trial and error. So let me know if you need more time. No? All right. All right, so next thing we want to do is rotate this thing. And another thing that Registax is really good at is rotating these images without messing up the entire image frame. So over here in your functions here, you'll see a flip and rotate button. I'm going to hit that. And I'm just going to kind of eyeball it to right about there, a little bit more. Just going to drag this little arrow to get it roughly where the South Pole is south. And there are, you know, different schools of thought as to whether that should be on the top or the bottom. But for me, south is bottom. And if you want to fine tune it, you can do so with the numbers here. So that looks pretty good to me. All right. Now, one more thing we should talk about. I'm going to go back to the full image here. You're going to see there's this kind of like artifact around the edge here. This is kind of, people call this different things. It's like the edge rind effect, a lot of people call it. It's actually an optical diffraction pattern. It's a knife edge diffraction artifact. There is absolutely nothing you can do to prevent this. Everyone gets this. Even, you know, the pro imagers get the same thing. And you might say, Frank, why don't I see this like weird line on all these images that I see online or on the astronomy picture of the day? It's because people fake it. They like blur that out. They use the clone stamp tool. They do something to like obscure that artifact on the edge because there's nothing you can do about it. It's like an optical pattern. You know, unless you have an infinite aperture on your telescope, you're going to get it. So there are different ways of dealing with it. I am going to deal with it in Photoshop because I find that's the least intrusive way. But there is a way of dealing with it in Registax as well that I'll show you just for reference. If you click on denoise de-ringing, you can activate de-ringing. And for this case, it's going to be on the bright side. So deselected dark side, I selected bright side. And if you turn this up, you'll see it kind of blurs out the edges there. So it looks okay. Like, you know, if you wanted to like just be done with it, that's not bad, you know. I might want to push that a little bit further. You can still kind of see an edge there. So for a final result, that ain't too shabby. You know, you might want to tweak the gamma a little bit, but I personally would choose to do that in Photoshop, so I'm not going to do it here, but that gives you more of a rich color, right? So it's a little bit more Mars-like by reducing the gamma a little bit, but I'm going to do that in Photoshop instead. But that's Registacks in a nutshell. So it really comes down to experimenting with these wavelet layers. Again, 2, 3, and 4 is probably where the action will be. You're probably going to want to bump up the denoise on layer 1 to get rid of any noise artifacts around the edges. And you're probably going to want to increase the sharpening if you had good enough seeing to support it. Again, the real takeaway here is don't go too far. An over-sharpened image might look good to you, but it's not going to look good to you tomorrow morning. It's not going to look good to your friends. So, you know, it's very easy to push that too far, saying, oh, I can get more detail out of it, but it just ends up looking artificial, and it is artificial if you go too far with that sharpening. But I think that looks pretty good. So I'm going to save this. So to do that, I'm just going to say do all to apply everything to the whole image. And then I'm going to say save image. And I'm going to give this a unique file name so I don't lose my original stacked image, because that took so long to produce. I don't want to have to do that again. So let's call this Mars Sharp. And make sure it's a TIFF. You want to make sure that you have as much color depth as possible. All right, so we're done with sharpening. And now we're on to final tweaks in Photoshop. If anyone wants me to stop so they can catch up, this is your chance to holler. We good? All right. All right, so I'm going to close out of Registacks, and you could call it done at that point. Oh, did I leave that deraining on? Phooey. Let me redo that real quick, because I wanted to show you how to do that in Photoshop. Actually, what I'm going to do is open up a different one. I had a pre-baked one that I'll use. So let's open up Photoshop, or the image editor of your choice. Doesn't really matter. We're not going to do anything terribly fancy. And I'm going to open up my Mars Sharp image that I made. And this is actually one that I made yesterday, where I did not apply that de-ringing. All right, so Robert Scott has to run. Thanks for joining us, Robert. I will be posting a recording of this later, so if you want to catch the end, you can do so later. But we're almost done. You can probably guess what we're going to do right now. Just play with the colors and stuff mostly. So let's blow this up, fit it to screen. And I'm going to show you how to get rid of that image rind effect there in Photoshop. Best way is to use the clone stamp tool. And it sounds sketchy, and it is, but you got to do what you got to do. So I've got this set to about 10 pixels for the brush size, and the opacity is at 70%. All right. And the way the clone stamp tool works is you hit the Alt key while clicking on an area just beside what you want to cover up. So down here, that rind is like at this angle here. So I want to like get a little bit to the right and above it. I'm going to hit Alt and click, and then move down to where that line is and very carefully draw over it. You see how it's making that disappear? Now,
what did you call that tool?
Clone stamp.
Clone stamp. I'm a twin. I should like that. Thanks.
Yes. Now, as I move up this curve, like I want to use a different reference point. So I'm going to go a little bit more to the left now here, hit Alt again, and click to say where I'm sampling from. And it's going to clone the pixels from that region to the region where I click and follow that as I move the cursor up. So let's keep on going. And you want to be really careful because you don't want to like mess up the edge of the image here. That would be bad. There's a little bit of a diffraction thing going on here that I'm going to try to cover up as well. All right. Right about there is the edge of that artifact.
Hey,
now,
Frank,
yeah.
Creating a mask to put over the or around the planet won't help prevent that?
Yeah, it can. It's just more trouble. So if that makes it easier for you, by all means, do that. A mask can definitely help. I'm not a Photoshop expert by any means, so if you're comfortable with making masks.
No, I mean during the Registacks
processing
of it, that's creating the artifact. Wouldn't a mask get away from that?
Yes, you're right. That is another way of dealing with it. If you restrict your sharpening to just the middle of the image, that will make it less apparent. It will still be there because it is fundamentally a diffraction effect. But you know, if you're not sharpening it, it's at least not going to make it worse. So yes, you're absolutely right. It is possible to make a mask in Registax. If you play around with the mask feature, it's pretty easy to figure out, but getting it to look right is a little bit tricky. You know, it has to be just right. You know, you want to sharpen as much of the image as you can, and that mask tends to restrict that sharpening a little bit too much in my experience. So I find it's a little bit easier to use the clone stamp tool in Photoshop to make sure that I'm preserving as much of that sharpening as I can, if that makes sense. Now, the intellectually honest thing to do here would be to blur that out, because that's fake information. It's not really there. So to make myself feel a little bit more justified in what I just did with the clone stamp tool, I'm going to blur it out. So I'm not giving people the impression that detail exists where detail does not exist. So I'm just going to rub that out a little bit using the blur tool and cover that up a little bit. And that's also going to blend in the edges of that clone stamp as well, make that look a little bit nicer. All right, so that looks pretty good. There's a weird thing here I want to blur out too. A little bit better. All right, so keep in mind this is blown up. When we reduce this, it's going to look a little bit better. Now, next thing I want to do is see if I can push the sharpening a little bit more. So let's put this back to 100%. Looking all right, yeah. Before I do that, let's adjust the gamma. It looks a little bit washed out to me. So let's go to image and go to adjustments and go to exposure. And I'm going to reduce the gamma to like 0.8. And you know, that is kind of an artifact of how you captured it, how the camera responds. It's a justifiable thing to do physically. So that looks a little bit more Marsy to me. And now we can try to sharpen it a little bit more. There's a couple of ways to do this. If you don't have Topaz, the built-in filter that I find works the best is Smart Sharpen. So if you go to Filter, Sharpen, Smart Sharpen, the trick here is to find the radius size that captures the features that you want to sharpen the most. And the best way I found is to start by turning the amount all the way up to really make it obvious what this is going to do. Make sure this is set to Gaussian blur for the best results. And I'm going to play with the radius and just see what effect it has. So you can see that 2.1 pixels is too much. Those features are too large. Usually it's going to be around 1.7. It's going to be, or 1.5. Right around there looks about right. But obviously 500% is too much. We're just going to play with this until it looks reasonable. So I don't want to over sharpen again. And you can kind of toggle on and off the preview here to get a before and after view. So yeah, that's kind of too subtle. Let's try to move this like to the middle somewhere. A little bit tough to see, but it's definitely making a difference. I'm looking at the main image here and seeing how it compares before and after sharpening. You can see we're definitely pulling some more out of it. I think that's a little bit too far, actually. Right about there, looks good. Maybe dial that down a little bit. Again, less is more. You don't want to push this and try to create more detail than you have. But that looks pretty good to me. So yeah, that's pretty close to a finished image. I'll show you one other way to do the sharpening though. I'm going to undo what I just did and show you what Topaz Sharpen AI looks like. It's very much hit or miss, I find. Sometimes it does amazing things and sometimes it does terrible things. So let's start by blowing this up a little bit so we can see what's going on. And if you're lucky, you can just hit the auto button and see what it does. That's not too shabby. You can hit the original button here to see what it looked like originally and what it came up with. I think it's over sharpening a bit, so I'm going to dial that down a little bit. That looks more reasonable to me. So let's go with that. Looking pretty good. And now we're just down to like final tweaks. If you want to like mess with the saturation or something, you can. You know, this is like kind of getting into the artistic aspect of it. with color cameras or one-shot color cameras in particular, it is justifiable to bump up the saturation a wee bit. Just makes it pop a little bit more. Around 10% or so is probably a good setting. Again, you don't want to push it to ridiculous levels. Just make it look Marsy. And yeah, at that point, I'm pretty happy with it. So at this point, you're ready to save what you got. Again, save it with a new file name so that you don't lose what you started with out of Registax. I'm going to call this Mars Sharp Process. And before you can share this on social media or whatever, you're going to need to export that to a web-friendly format such as PNG. So I'm going to say export. Quick export is PNG. And I'll have a PNG version of that image that I can post to my favorite online watering holes. There you have it. A processed picture of Mars that I think looks pretty darn good considering it was taken from the planet Earth. So I don't know how many of you have been following along or were able to, but hopefully you're seeing a similar image right now that you're happy with and proud of. And I hope you've learned a thing or two. You can go out and apply and capture your own Mars while it's near opposition. And yeah, thanks guys. If you have any last questions, I am definitely up for them right now. Thanks, Loa.
Hey Frank, I did have I think what I'm trying to wrap my head around is, so in I think it was called Registax, right?
Yeah.
The file you imported was a TIFF, right?
Yeah.
How big was it?
Yes, it was a TIFF. Sorry, what was the question?
How big was that file?
Oh, it shouldn't be too big. It was this one here, right? So.
Oh, not very big at all. No, that can't be right. Is that right?
No, that could be right. It's a small image.
Okay. It's blowing my mind that all the, like the wavelet layers, that all that is hiding in that file. Because when you pulled it in, it was so blurry.
I know.
And then like magically, just all this detail came out. And that's just really, so I was just trying to wrap my head around how just like a TIFF file is holding on to that much information, you know? It's crazy.
Yeah, I mean, fundamentally, it's still a pretty small image, right? So
yeah,
it's only.
It's crazy though.
It's only 468 by 432 pixels, so that's not a lot of information at the end of the day. So, but I agree, it seems magical. It's freaky how Registax works. Wavelets are awesome. Yep. Cool. All right, guys. Well,
was that the Topaz that you used? Was that an add-in that you have that's not stock in Photoshop?
Yeah, it is. It costs like $50 or something.
Okay.
But I find it's worth it. Sometimes it does great things. Sometimes it doesn't. But Smart Sharpen is pretty good too. I also have something called Topaz Denoise, which comes in handy for deep sky stuff a lot too. So that's a very useful tool too.
You don't have the upscaling one, do you?
I do not.
Okay.
Yeah.
I was going to ask you if you'd ever just tried to upscale an image, just like a planetary image, just for the hell of it, to see if it's how faithful it is, you know?
Yeah, I mean, if you've got it, like, I'd be interested to see what you can pull out of this thing. Because if you just do the obvious thing, just say, blow it up, it kind of looks like crap. So.
Although I guess that's what the drizzle's for. So really, it really wouldn't. I guess it really wouldn't be worth it because that's what the drizzle does.
Yeah, but drizzle can only go so far. We're still ending up with a pretty small image, right? So if I really wanted to print this or something, it would be kind of underwhelming. So I think there's still a use for some AI-driven enlarging as well. Drizzle is always better because it's actually going to be pulling out real information, whereas the AI is going to be fabricating information. But if it looks good and inspires people, that's what matters. We're not scientists here. At least I'm not. All right, any more questions?
Yeah, Frank, do you use an application to show you what Mars looks like according to Hubble or something or other at the time that you take your picture?
Yeah, I mean, Stellarium can do that, right? So that's all I used to like figure out.
Stellarium?
Yeah. Like if I want to know if the Great Red Spot's going to be out, I just look at Stellarium. It's actually pretty accurate.
Yeah, the red spot is one thing, but we're talking about Mars here. The surface shifts around an awful lot.
Oh, I see what you mean. Yeah, like dust storms and stuff. That's true. No, the short answer is no.
There are some firm features, yes, but like I was having an awful hard time looking at a map of Mars and fitting that particular image to that map of Mars.
Yeah, I know what you mean. You know, the first good image that I got out of my new system, I was like looking at maps and trying to figure out what the heck I was looking at, and it was not obvious at all because, yeah, it's a dynamic place. I mean, this is what Stellarium says it should look like at, you know, 1:44 a.m. tonight near opposition or near transit, but what you see is probably going to be kind of different. I mean, it's not like
you might want to try the Alpo website. There might be recent images posted, and you might get lucky there.
Yeah, Astrobit as well. You know, you can always find someone who took an image of Mars last night there. The rotation might not be the same as what you're getting, but you'll probably find someone looking at the same face. While I reboot my camera again. All right, well, with that, I think we are done, guys. So thanks for sticking with me for an hour and 45 minutes. I hope it was worthwhile. And learned a few tips and tricks. If you want to follow up or have any questions for me, feel free to communicate with me on Groups.io, track me down at a meeting when the day comes that we can have in-person meetings again, or you can reach me at fkane@boldly-going.com. And I'm always happy to help. So get out there, guys. It's good.
That was great. That was great, Frank. Thanks for doing that.
My pleasure. Thank you. Thank you for showing up. All right. So I'll post a recording for this when I get around to it. But thanks for coming, guys. It was good seeing you. And get out there and enjoy a good night. Take care.